In this video, we will go over how to solve problems you face in curvilinear motion, normal and tangential components. Basically, this chapter asks you to find the normal and tangential accelerations and the magnitude of acceleration. There are three new equations you will end up using quite often. The first is an equation relating normal acceleration with velocity and radius of curvature. The second is an equation to find the radius if an equation is given for the curve. The third is to find the magnitude of acceleration. The other equations you need are ones you probably faced a lot already in previous chapters. Let's go through some examples so that we can apply the new equations and see how and when to use them. In this question, we need to figure out the magnitude of acceleration when the toboggan reaches point A. Let's look at the question and the diagram to see what information is given to us. We know the equation of the curve, we also know the velocity at point A, and we know the acceleration. The letter v with a dot on top simply means its acceleration, or one derivative of velocity, which again is acceleration. Now since an equation for the curve is given, we instantly know we need to figure out the radius using the radius of curvature equation. That equation requires three things: the first derivative, the second derivative, and the value of x at the location where we are trying to find the radius. In this question, you can see that it's at x equals 60 meters. So let's do the first derivative of this equation. Now we can do the second derivative. Since we found both derivatives, we can plug it into our radius of curvature equation. To find the radius at x equals 60 meters, all we need to do is substitute that value into this equation. Solving gives us the radius of curvature. Now we can apply the second equation we talked about to find normal acceleration. We know the velocity from the question, which is 10 meters per second, and we just found the radius. Let's plug them in and solve, which gives us the normal acceleration. Something to remember is that normal acceleration always points towards the center of the curve, while the tangential acceleration points along the tangent at the point. The tangential acceleration is also given to us in the question, which is 3 meters per second squared. So now we have both accelerations required to find the magnitude. Now we can use the third equation we talked about. Let's plug them in and solve, which gives us the magnitude of acceleration. As a side note, in some rare questions, you might have to use the radius of curvature equation with respect to the y location instead of the x location. That simply means the derivatives you take will be with respect to y instead of x. That way, you can substitute a y value instead of an x value. Let's do another example. In this question, we have to find the speed of the truck and the magnitude of acceleration when it moved 10 meters. You can see that we are already given the radius, so we don't need to use a radius of curvature equation. We are also given the velocity at s equals 0 and the acceleration with respect to distance. So let's think about the problem. To find the normal acceleration, we know we have to use our normal acceleration equation, which means we need the velocity when the truck travels 10 meters. So that's what we need to find first. We can use an old equation relating velocity and acceleration to find it. v dv is equal to ads. Taking the integral of this equation would give us an equation for velocity, so we need to think about the lower and upper bounds of the integral. The velocity starts from 4 meters per second, and the distance starts from 0 meters to 10 meters. So this is what our integral looks like. Solving gives us an equation where we can solve for velocity. Solving gives us the velocity of the truck when it moved 10 meters. Now, it's a simple matter of plugging in the velocity and radius into our normal acceleration equation. Let's solve to get our normal acceleration. The tangential acceleration also needs to be found. It's actually given to us in the question. All we need to do is substitute 10 meters to figure it out. So let's do that, which gives us our tangential acceleration. The magnitude can be found using this equation. Solving gives us the magnitude of acceleration. Let's look at one last example. In this problem, it's asking us to find the magnitude of acceleration when the jet is at point A. Looking at the diagram, we see that the curve is represented with an equation. So the first thing we have to do is take the first and second derivative of the equation. Let's start off with the first derivative. Now the second derivative. Now we can plug them into our radius of curvature equation. Looking at the diagram, we see that the x value at point A is 5 kilometers. So let's substitute that into our equation, which gives us the radius of curvature. Now we can find the normal acceleration. The velocity is given in the question, which is 200 meters per second, and we just found the radius. So let's plug it in and solve. The tangential acceleration is also given to us in the question. It's 0.8 meters per second squared. To find the magnitude, we just need to use our magnitude equation, and solving gives us our answer. Most, if not all, questions in this chapter rely on 3 new equations I showed at the beginning of this video. There will be some questions where trigonometry will be very useful, but the core of the problems still rely on the 3 new equations you have to use. I listed some other solved questions that might be challenging in the description below. Thanks so much for watching, and I hope this helped. Best of luck with your studies.